Hello, Jermaine here, and in this video we're going to resume with our series on building RESTful web APIs using the Aqueduct framework. In the last video, what we did was we looked at routing in further detail, and specifically what we did was we built an endpoint called reads. The purpose of that was we used it to manage a list of reading materials. And so this endpoint is bound to a controller which is responsible for handling requests that come to our endpoint. So this controller is capable of performing CRUD operations. So we had get operations, we had post, we had put, and we had delete. So in this video in particular, we're going to refactor the body of our request. And the way we'll do that, I mentioned in the last video using what's known as HTTP serializable. So the actual class we need to extend is called serializable rather than HTTP serializable. I think it used to be called HTTP serializable, but as of Aqueduct 3, it's now serializable. Anyway, but we're going to use this class to help decode essentially our request payload. And once we've done that, we're going to refactor that a bit further by making that our model, which would represent our item in the database. So without further ado, let's begin. The first thing I'm going to do is to refactor our imports. So instead of doing this, I am instead going to import package, the name of our package, which is favorites. So we get this name from our pubspec.yaml file here, and then which will bring us to this lib folder. So then we'll import channel dart, no, actually, sorry, not channel, favorites dart. So I'll show you what's in favorites right now. So in favorites, we're exporting essentially the data async module, and we're exporting the Aqueduct package. So I think it makes much more sense to import our library instead of these packages directly. Okay, so the second thing I wish to do is to refactor these routes using cascades. You don't have to, but it looks nicer in my view anyway. So what cascades looks like is using the double period and get rid of that. That way. That way. Okay. So using this cascade operator, we're able to call, essentially we're able to do this, and then which returns the router instance, and then we're able to chain a lot more. So I mean, if you've done jQuery, for instance, this should be kind of familiar. And instead of returning router, I'll get rid of all of this and use the shorthand way. So if I save this, yeah, it will look like that. So that looks cleaner anyway to me. And so coming back here now, Aqueduct allows essentially operation methods to bind properties of a HTTP request to its parameters. So what that means is using methods like bind.path, we're able to essentially bind the path variable ID, which is part of the HTTP request, to this variable called ID, which allows us to use it in this operation method. update read. So what that means is that a request body can also be bound to a parameter. There is bind.path. There's also bind.query. There's bind.body, which we're going to use in a bit. There's also another last type of bind. I forget what it is, but you can look in the documentation. Is there. So we are going to bind the body, the request body, or the request payload, rather, to a parameter in here, which we'll be able to use in our operation method. So what that looks like is that. So we do bind.body, and then we'll specify the type that we wish for it to be bound to. So that type would be called read. Now it's not there yet, but we're going to be defining that soon. And then we'll give it a name, which is body. So in order to bind to a type, we need a type that extends the serializable class. So at this point is where we'll be extending the serializable class to create a type that we're able to use in here. So to do that, we are going to come to our lib folder, and we're going to create a new folder. We're going to name that model, and then in model we'll create a file called read.dart. In this file we're going to import our favreads package, which contains the imports for Aqueduct, so we don't need to import it directly. And then we'll create our read class that extends serializable. So we'll get a red line, which means that we need to implement two methods, asMap and read from map. So what asMap will do is it will take the instance properties from read, and then it will convert it to a map. So this method will be called by Aqueduct when a response is being generated from this model. And read from map is essentially the other way around. So it will take in a map object, and it will destructure the key and value pairs, and it will assign the values to our instance properties here. So let's define our instance properties, which if we come back to our controller, it's a title, author, and a year. So we'll do that here now. So we'll define a string called title. We'll define our author as a string, and then our year will be an integer. And then let's use the override annotation, because we are overriding the methods in serializable. So we've got asMap map here, which will give us a map where the value is dynamic. And then so in here we will return a map object, which will for the title we'll assign title. Essentially we will do the same for author and year. So author and year and year. Right, so we'll return an object containing title, author, and year. And in fact, let's use the shorthand form of it. So that looks like that. I'll get rid of that. So if I save it, and I'll add a comma here to prove the indentation for it. And the second method we need to override is our read from map. So it's void and then read from map, which the parameter is a map of type string dynamic, and then its our request body. So from here, we'll extract the title key from our request body, and we need to call toString, which is because we're trying to assign a dynamic type to a type of type string. So to prevent any errors running, we just use toString to convert it to a string. So when we'll get the author from our request body, and then finally let's get the year. And in fact, year is an integer, so we'll wrap this in an int.parse. So our source is our request body year toString. Okay, so I'll save this file, and then I'll come back to reads controller and then import our file. So we'll import model read.dart, and to use this, we'll start by essentially refactoring, changing these maps to use our read class, or specifically our read object. So we'll create a read object, and then we'll call the read from map method, which will take this map object. So let's do the same for these two. Okay, that's good, and I'll just put that there. So that means we can come back and refactor this part. So we're getting an error, which, yeah, we can get rid of that. That should fix it, and we can get rid of this one as well. And then we need to include this, bind the payload body to this variable. Okay, so I'll save that as well. Make sure all files are saved, and then let's run Aqueduct serve and test it. All right, good. So let's try our get request. Okay, that's good. Let's do a post. Let's add this to it. Okay, success. And let's do a get again. We should now see 4 items. Okay, that's good. Let's do a put. Hit send, updated read. Let's do a get for item 2, which you see there, and do a get slash reads, and then yeah, we see the replacement done as part of the put request. And then let's do a delete. Let's remove the item at 2, deleted read. So now if I do a get to 2, no, we shouldn't see that. Oh yeah, of course we should see that, yeah, because there's always 2. So if I do a delete again, item 2, item at index 2, then that means if I do a get request for item at index 2, we should get item not found. Yep, which is because there is the item at index 0 and item at index 1. So that's working perfectly. And now we need to refactor our serializable class, but we'll do that later. In the meantime, what we need to do is to set up a PostgreSQL database. All right, so let's get onto it. In order to connect to our database, if you read this part of the documentation on the Aqueduct website, they recommend using postgres.app to set up a development database quickly. So this is what the website looks like. You can just read, you can follow the instructions and get it installed on your machine. Unfortunately, this is just for Mac users, but I did some little research for Windows and I came across this solution, Big SQL. I haven't used it myself, but I guess I'll recommend starting off with that. Claims to be complete and developer friendly, so here's hoping. But if you go to, if I hit download, you've got different options. So you can try this. You can try this one if you're on Windows. Okay. And also, if you follow the instructions and install Postgres app on your Mac, you should get this icon at the top right nav bar, and then we can open Postgres, which will give you a list of databases already running. So I'm going to double click on any of the database, which will give me a terminal prompt. I'll just allow that. Okay, hold on. So I enabled accessibility features for the Postgres app, which now means that we should be able to open our terminal prompt. And also the second thing I did was in the instructions here was to configure our path to include to use the included command line tools. Yeah, so I did that as well, which is important. So that now means that the terminal would give us the PSQL prompt. And in here, all we just need to do is follow these instructions here. So we'll create a database. We'll create a database called favorites. I'll call it favorites official. And then we'll create a user. I'll just call it favorites user. And I'll give it a very secure password. All right. Sorry, my bad. So I need to put a semicolon here. And then once that's created, then I can do this bit. Okay, that's good. And then we need to grant all on database, favorites official to favorites user. Oh, let me zoom in a bit more. Okay, so that should be good, which now means that we can log into our PostgreSQL database, with these details. Right, so we have our model here called read, and the first thing we need to do in our model here is we need to so essentially we need to build our data model, which will be based on the rows in our database. So the first thing we need to do is we'll change this read class to _read, and then we'll remove this extends line, and then we'll get rid of this stuff. So this is the first thing we'll do, and then the second thing is that will allow us to create a read class that extends what's known as a managed object. So a managed object is used by Aqueduct to essentially convert this into a usable object that we can interrogate in various areas of our application. So we need to extend manage object that implements underscore read, and then we'll need to annotate the properties of our underscore read class. So this is in fact known as a table definition. So this is a table definition for our database, whereby the name of the table in the database would be underscore read, and then it will have these columns. So you'll have a title column, an author column, and a year column. So we'll start by amending this definition to take in a primary key, which we'll call ID, and then yeah, we'll have a column, and then in this column, I guess, yeah, we'll make the title unique, and then we'll have an author, which would also be another column in our database, and we'll make this another column. And also this read class is what we'll be basing our query objects from. So we'll create a query object, and then we'll use this read class as a means of interacting with the underlying table in our database. Also, the reason why there are two classes is that the properties and methods we define in here are known as transient, which means that the properties that are defined here will not be stored in this database column. So it's quite useful because you would want some values that are computed based on the columns from our database table, rather than storing it directly in the database table. So here's an example. So I can create a string and a getter for, I'll say, I'll call it detail, and this would return a string that just says title by author. So this is kind of equivalent to computed properties, or if you use the Mongoose.js, they call it virtual properties. So computed properties, virtual properties, yeah, choose whichever term you like. But yeah, essentially this will not be stored in our database table because they are computed based on the title and the author. Okay, so that's all we're going to do here, and then we will come to our channel.dart, and what we need to do here is to prepare essentially our connection to the database. So we need to do two things here. Firstly, we need to tell our application what our data model is, and secondly, we also need to tell our application channel which database we expect it to connect to. So first thing we'll do is get rid of this, and then we'll create a managed context, which we'll call context. And then in here, we'll create our data model. which what this does is we use a managed data model from current mirror system. So from what I understand, this would essentially search our library for all subclasses of managed object. So essentially it would search our library, and it'll search for all of these, and it'll sort of capture those for us. So that means we wouldn't have to import this manually. Secondly, we need to create a persistent store which holds our connection to the Postgres database. So what we're looking for is a PostgreSQL persistent store from connection info. So it takes these details: a username, a password, host, port, and database name. So our username, we called it favorites_user. Our password, we just called it password. The host is localhost. The port number is 5432, and the database name was favorites_official. Let's save that. Okay, that's good. And then the last thing we need to do is to assign a value to our context, which is a managed context. So yeah, that'll take our database, our data model, and then it takes our persistent store. So at this point, although we have our managed context, we still need to set up our table for the database, because our tables doesn't exist yet. So in order to do that, we need to create a migration file. And the way you do that is we run this command, aqueduct db generate. So if I run this, and what that does is it will generate a migration file for us. So I'll wait till it's finished and I'll take you through it. Okay, so it's the migration file is generated, and it's in. So when that's done, you see a new folder called migrations, and then in here you see your initial migration file. So initial.migration.dart, and in simple terms, so a migration file is a Dart script which would run the necessary SQL commands that would alter your database. So in this example, you can see here we're creating the table for our database, and then we're creating all our columns in our table. And of course, it's able to do that because it looks for all subclasses of managed object, and it's able to generate the right table and the columns from that. Okay, so in this file, in fact, we can run this file directly, and it will generate our database for us, including the columns we want. But I want to come down here to this method. So what this seed method will allow us to do is to put some data in our database. So I'm gonna do that here, and essentially it will be based on the information we have in our reads controller. So I'll come here and I'll copy all of this. Copy that, and if I come to this file, I can paste it in here. And I'm just gonna tidy this up quickly into a list containing map object. So let me speed this up. All right, so now that's done, what we can do is we can now execute a database query for this. So for final read in reads, and because it's using async await, we can await. Then we'll do database.store.execute. So here we'll pass in a SQL query, which would be insert into our table name read, and then we'll insert title. Was it title author year? So title author year, and then we'll insert these values. So the values would be passing a placeholder string, title author, then year, and then the second thing this takes in is substitution values. So substitution values, which is a map. So in here, the title would be read title. The author would be the author. And as you've already guessed, the year would be the year. So I'll save that. Let me come out. Okay. So just to recap, we are just creating this list of predefined items for our database, rows, and then we're executing a SQL query to populate these rows with the values from the map. So I'll save this one here, and then I can come back here, and then I'll do Aqueduct DB upgrade. Oh, right, sorry. It's a much longer command. Yeah, so it's Aqueduct DB upgrade, and then we pass in the connection information, which is the Postgres protocol, and then followed by the username, which we called favreads user. Let me extend this. Let me kill this server and kill that. Okay, so at least you can see a bit clearly. So favorite user, followed by colon, and then our password at localhost 5432, and then the name of our database. So it should be favorites official. Yeah, so that should work for us. Okay, that is good. Okay, so once that is done, the next thing we need to do is to allow our resource controller, read controller, to be able to perform, essentially to make queries on our database. So we'll do that by going to our reads controller, and then in fact I'll get rid of this because yeah, we won't need it anymore. That means we'll get all these errors. I will fix them later, so that's fine. And I'm going to declare a constructor here for our reads controller, and this constructor would take in a context. So this would be called context, and we need to declare our managed context in here. So essentially take that, but I'll do this.context so that it will automatically assign whatever we pass in here to the context object. So let me shift this to the top. Just do some formatting. Okay, cool. And then the next thing we need to do is in order to query our database, we can create query objects. So what that looks like is for our get operation. Example, I can declare a read query, and then we'll create a query object, which essentially is a generic type class, and then it will take our managed object that way essentially, and we need to feed this query object our managed context, so it's got a connection to the Postgres database. And then what we do here is this read query now gives us various methods we can call. So we can do an await, and we'll do read query dot fetch. It will just fetch all the rows in our database and return that for us. Okay, and then let's just test this quickly, but just so this doesn't throw, I'll declare a list of reads. I'll declare an empty object for now. So let's save this file and let's test this one in particular. And then before we test it, we need to pass in our context to our reads controller instance. So I'll do that right here. So I'll save this file, and then let's do an aqueduct serve. All right, so it's running, and let's test it now. So if we do a get request here and I do a send, it should send us a response containing our items with the ID as well. So that's good. Okay, that's awesome. Now we can, of course, go and amend our other handler methods to use this query object. So for this one, we can do, I'll say, let's create our query. So create our read query. And then we pass in the context. And then essentially what we need to do is we're filtering by ID. So using Cascade, we can do where, and then we'll say where gives us the item in our database, and then we will grab the ID of our item, so read.id, and then we've got another matcher method we can use equal to the ID we've passed in here. So now we will create our, we'll make the request by doing await read query, and we want to fetch one item from our database. So from that we can change this condition. So what fetch one will do is it will look in the database for a matching item with the ID we've specified in the path parameter. If it doesn't exist, read would evaluate to null. So we can do if read is equal to null, then we'll send a response not found, else we'll send the read that we found. So let me save this and then I'll try that. Okay, so we do for reads, that's good. And then let's search by ID 3. Perfect. Okay, we got it. Now for post, so something similar, we'll need to create a query object. So read query. Pass in a context and mutate our query slightly by using values. And values is a reference to our read managed object. So what we do is we'll essentially set our values to our body, and then from that we'll create a variable called inserted read, and then we'll insert it into the database by doing query dot insert read query dot insert, and then in the response I'll just return our inserted read. So let's save and let's give this a go. So let's make a post request. Then in the body of our post request, we'll give it these details. It'll be to the reads endpoint. Oh, I need to restart server. Okay, so now that's restarted, I will go ahead and make this post request. Okay, awesome. So we got our item inserted with an ID, a newly generated ID. So if we now make a GET request to our reads endpoint, we should now see 4 items. Okay, that's good. So now let's look at our request, our update request. So similarly, we will build our query. Read query. Then create query object, read, takes in our context. And then what we want to do is where read, we grab the read ID is equal to our ID passed in the path. We also need to assign the updated values from the payload, request payload, and then from here we can do updated query. We can have wait, read query dot update. Since we want to update 1, and then in here we'll check if the updated query is null, which means that it doesn't exist. Else, if it's not null, then we can just respond with the updated query, really. So you can do that. I'll get rid of this bit, save that, restart the server, and give it a go. Okay, cool. So let's do the get again. Okay, and let's update this one. So we do a put to read, and we'll update this one in particular, and we'll call it code completer updated edition. Okay, so let's send this. if I send this, yeah, we should get an update done, and it's returning a 200 response, so that looks good. So now let's do a get request to read/4. It gives us that, and of course we do a get request to reads, then it shows the updated one. Okay, that's good. So now let's implement our delete functionality. So as expected, I will create a query object, and then it will be query read, which takes in our context, and then we want to filter where the reads ID is equal to this ID that we passed in through our path variable. And what we want to do is we want our deleted read, which we'll do on await read query dot delete. And so this actually returns an integer. So in fact, if I hover over this, so yeah, the method will return the number of rows deleted. So I guess I should call this deleted. Yeah, I call this delete count, so it makes a bit more sense. So essentially, if the delete count is 0, then we'll respond with item not found. Else, we will just respond and say, yeah, deleted read. Or I'll say, or actually let's say delete count items. So I'll save that, and then restart server. Okay, restart it. So let's do a delete to remove the fourth item. So if I do that, it says deleted 1 items. Okay, so if I do a get to read/4, should not be found, which is because it's been removed. Okay, that's good. And the last thing we need to do is now get rid of this reads list. I think we don't need it anymore. Right, so just to recap, we've created query objects to handle our different CRUD operations. We started by capturing the context, our managed context that we defined in channel.dart. So this context that we defined here, and then we passed it into our reads controller, which means that our reads controller can now access the database, and our reads controller understands the data model or the data representation in our database tables. So from that, we've constructed various queries and made it specific in some cases where needed. So now we're able to perform CRUD operations in our Postgres database. Okay, so let's go through all of this one more time. So we can do a get to our reads endpoint, and then we can do slash, and then select a random item, which should give us clean code, a handbook of agile software craftsmanship, and then we'll do a post, and then we'll add this item to our database. If I do a send, we get a 4.5 method not allowed because that's the wrong endpoint. So it'll be post/reads, and then we'll try that again. So will give us a new ID because we deleted the item with the ID 4 and ID is auto incrementing, so that is fine. And we can do a put request, and I'll make it read /5, and I would just get rid of this bit, updated edition. And then if I do a send, we get our update. So I can do a get, which will give us our updated read, and then gets to /reads, which we see our update here. And then we can now do a delete request, and we'll delete the item with the ID of 5. So we get deleted one item, which means get to the item with an ID of 5 is now not found, which is great. And of course, if we do a patch, we get a 405 method not allowed. So Aqueduct handles that for us, which is good. And so I think this now brings me to the end of this video. And I truly hope that you learned something from this. This was fun for me while doing it. And also, if you want to learn a bit more, you can go to the Aqueduct documentation. It's surprisingly well documented. So all these methods, if none of these made sense, you can ask questions in the comments below, or you could go to aqueduct.io. They've got loads of examples, so you could check this out yourself. And I just want to say thanks for watching this video. If you liked the content presented, do consider subscribing, do consider liking this video, and also once you subscribed, hit the thumbs up, not the thumbs up, hit the notification bell icon, so at least you're updated when new videos are released. So thank you.